Okay, let's start with number 18 on our review. The question is, which graph shows a function with a domain of all real numbers greater than 7? Now remember that our domain is all of our x's. So we're looking at our x-axis of all real numbers greater than 7. So I know that 7 is going to be where it starts. So that's this one, not that one, and yeah, this is at 7. So that's possible. But I need to show the domain of all real numbers greater than 7. And that's going to be, it's got to be A. This is talking about range less than 0. So that ain't it. This is talking about range greater than 7. That's not it. And this is a domain greater than 0. That's not it. This is the only one that has a range, or sorry, a domain greater than, so this should be open, greater than 7. So A is your answer for 18. All right, number 19. For the function w, w of 9 is equal to negative 7, and w of negative 7 is equal to 9. So if y equals w of x, what is the value of y when x is equal to a negative 7? All right, so when x is negative 7, let's look at all the clues we have here. When x is a negative 7, this is the one we're looking at right here. When x is a negative 7, then it's 9. Y is equal to w of x. And when x is a negative 7, w of negative 7 is 9. So our answer would be 9. On the bubble, on the answer document, make sure it's 9 decimal. Don't do 0.9. It's just 9. So let's go back to this and look at it again. For the function w, w of 9, that means when x is 9, then y is negative 7. But when x is a negative 7, the w of negative 7 is 9. And then they tell you right here, y is the same thing as w of x. So what's the value of y when x is a negative 7? This is the one we're looking at right there, and that value is 9. Next question. Okay, on number 20, this is a scatter plot, obviously. Let's look at what it's talking about. A teacher collected data on 20 students for 2 different quizzes. So 20 kids, 2 different quizzes, and here's the data. The first, the x-axis is points scored on quiz 1, and then the y-axis is points scored on quiz 2. So the scatter plot below shows the relationship between the number of points scored on the first quiz and the relationship with that and the number of points on the second quiz. All right, so let me move this up just a bit. So which statement describes the data? So let's look at each answer choice and see which scenario matches what we see in the data. The number of points scored on quiz 2 was less than the number of points scored on quiz 1 for any student who scored at least 50 points on quiz 1. So if we look on quiz 1 and look at everybody that scored less than 50 points, which would be this group right here, it says the number of points scored on quiz 2 was less than the number of points. So when they scored a 40, they scored a 30, that's less. When they scored a 35, they got a 30, that's less. When they got a 30, they got a 25 and a 10. Yikes, people. And then when they got a 25, they got a 20. So all of those are less. So the number of points scored on quiz 2 was less than the number of points scored on quiz 1 for any student who scored at least 50 points. Scratch that. I just, at least I need to be looking at this data right here. So if they scored at least 50 points on quiz 1, did they score less on quiz 2? So if they scored a 50, they got somebody got a 35, somebody got a 40, somebody got a 45. That's less. If they scored a 55, oh, they got a 60 here. So because of this, and also because of these, and because a lot of these, we have to rule out letter F, because some students disprove letter F. Some students got higher on quiz 2 when they scored at least 50 points on the quiz. So we know it's not F. All right, let's look at the next answer choice. The number of points scored on quiz 2 was greater than the number of points scored on quiz 1 for any student who scored 50 or fewer. So I'm looking at the 50 or fewer on quiz 1, which is that. So let's see. The number of points scored on quiz 2 was greater than the number of points scored on quiz 1 for all these kids. No, they got a 40 on quiz 1 and got a 30. So this one right here disproves what G says. So it's not G either. So all I need is at least one student that disproves it to count it out. Letter H, the number of points scored on quiz 2 was greater than the number of points scored on quiz 1 for any student who scored at least 50 points on quiz 1. So at least 50 points on quiz 1, and that's going to be this data right here. So we need to just make sure, is quiz 2 always going to be greater? Well, when it's 50, they got a 35, 40, and a 45, so that's not greater. So that rules that out. So let's hope that J is the answer before I even read it. The number of points scored on quiz 2 was less than the number of points scored on quiz 1 for any student who scored 50 or fewer points. So 50 or fewer are these kids again. And the number of points scored on quiz 2 was less than. So at 50, yeah, all these are less than 50. That's right. This 40, that 30 right there is less than 40. And at 35, this 30 is less than 35. So those check out. When they scored 30 on 1, they scored a 10 and a 25. So those check out. When they scored a 25 on quiz 1, they scored a 20. So all those check out. So that means J is a true statement. So this is just one of those where you have to make sure, first of all, understand the graph, and then you have to go through every answer choice, and as confusing as it is, make sure you get those key words, at least 50 or fewer, at least 50, or 50 or fewer. So make sure you understand that terminology, and make sure all the other answer choices are ruled out, and that leaves you only with one. Next question. All right, number 21. Let's read the question first. The number of ferry boat trips, which is represented with the function f of c, needed to transport c cars, so we know that c is the number of cars, in one day can be found using the function f of c is equal to c over 20, so the number of cars divided by 20. If there are no more than 5,000 cars transported by ferry boat daily, that's key information, no more than 5,000 cars, what is the range of the function? So I'm looking for the range of the function. What's the range? It's all my y's, it's all my outputs. So I'm looking for the range using this function. So I know that c right here is not going to be more than 5,000. So I know that's going to be my upper limit of my range. So let's plug in f of 5,000. That's it at the most. That's the most number of cars that can be transported. So let's figure what that is. So it's going to be 5,000, just plugging that in for c, divided by 20. So what's 5,000 divided by 20? When you do that division, you should get 250. So f of 5,000, the output is 250. That's the range, and that's the highest it's going to go. So let's look at our answer choices. The set of all integers greater than or equal to 5,000. Okay, they're trying to trick here. That's not it. Our greatest output is going to be 250. So it's not this one. The set of all integers from 0 to 5,000. No, that's the cars. This is not the range that we're looking for. The set of all integers greater than or equal to 250. Okay, there's our number right here and right here. So we've got to figure out which one it is. Now, we talked about how 5,000 cars is the most, so 250 is the highest of our range. So they could do less than 5,000 cars. So it's going to be everything from 250 and below, and it's not going to go below 0 because you're not going to have negative cars that can be transported. So the only one that makes sense is letter D. We know it's not greater than 250. We know that 250 is the maximum. So it's going to be less than 250, but also greater than 0. So D is the only one that makes sense.